Hey, it's me, Ronnie, and my light's working now. I didn't want to turn on. All right, I'm just gonna make an electrical portable heater for your home, like I've been using, like that, and efficiency and safety, and what to look for if you buy one. I said these are the most efficient ones I've found. Ceramic. They're little wire coils. It's going to take me about 20 minutes to show you all the safety. If you have to use an extension cord, yeah, okay, all right. This isn't using an extension cord, but I like to use one. I like to move it over to here for a reason, because it's a fan-forced air heater, not infrared. Now I'm going to explain that. If you don't have 20 minutes, turn it off now. But this thing's cool. Okay, I'm going to explain. First, efficiency of an electric heater. Same as the efficiency of light bulbs. You have electricity to make light. You want to make light. You don't want any heat. Heat is a byproduct that's wasted energy from making light. The same thing, if you want to make heat, you don't want to make light. And I'll show you the simplest way. Yeah, you get instant hot heat, but very inefficient. I'm going to turn off my light here, and I'm going to show you if I can make it happen. There, all right. Now I'm using just my light. My LEDs, 13 watts, but they put out heat. They put out heat, okay? But here's what you don't want to see in the electric heater. The ceramic ones, they run through a ceramic plate. They're not efficient. It'll say 100% on the power factor if you put it on high, but it doesn't put out the heat like this, a toaster. But the so-called dairy parlor heaters that have flat wires running, I'm going to show you, are not efficient. Okay? They got a fan, but they're not efficient because they make light. Watch what happens. The same theory with flat wires inside your toaster. Don't stick a fork in there. But I'm going to turn off the light. I'm going to push the lever down on there. Okay? Just one of them. And I'm going to turn the light off. And no light here. Watch, it'll heat up. You see that? You can see it. Look at I can see the wires heating up. That's in your toaster. That's, if you see that in a portable 120 volt plug in your own little outlet heater, that's not efficient. All the light that it is making is wasted energy. Woo, but it's nice and warm and it toasts your bread really quick, right? See all that light? That's wasted energy. It's not making just heat energy, it's making light energy. And that's wasted electrical energy, okay? Turn that off now. You got it, right? Oh, let me turn on the light. But you saw it. All right, I'm going to pop it back up. You saw that. Those heating coils in the yeah, they get hot and they make a lot of heat, but you're only going to get 1,600 watts of heat out of them. And the more light it makes, if you're trying to make heat, is wasted energy. Just like these LED lights up here, the more light I have, they're supposed to design for light. And any heat it makes above room temperature is wasted energy in electrical energy, okay? And I checked these at room temp. I'm going to turn them on. Yeah, and they're only 13 watt LEDs, but room temp is 66. And if you shoot it with the infrared gun, after 3 minutes, it's 89 degrees up here on the heat sink. Because these are capacitive dropper and stuff, and yeah, energy efficiency, if you ever put a meter on one, it's not even 100%, because, but we'll get into that next time. But here, watch this again. This is wasted energy, okay? I want you to see this. I just pushed the lever down on the toaster. But, oh, look, it's hot. That means it's making heat. Yeah, it's making heat, but look, it's making light. Get it? It's real, true laws of electrical physics. See the light it's making? It's still only making the max amount of heat it can, but every amount of light with my finger here that you can see, that's wasted energy. It's the flat wires, they get hot fast and but they still put out the same amount of heat, and they don't put out as much heat as what I'm going to show you next. Oh, I guess my toast was done. Okay, I got to leave that light off. Now I'm going to show you something. I said, I break these up. I don't get bumped. You need to hear I got it running. Okay, I'm going to show you. Now, okay, there's a fan is in front. The fan's in front here. It's a big circle, but it's only like a 4-inch fan. And then in the back is where electric wires go to make the heat, all right? You want to see highly efficient, let's watch. I'm going to turn off all the lights. I'm going to try to get a photo, video from the front and the rear, from here where the coils are back here, okay? The coils are right back here. They're wound little, and let's see if we have any light. If there's any light, that's wasted energy if you're trying to make heat. If you're trying to make light and there's any heat, that's wasted energy. Making heat when you're trying to make light, get it? I said, I've been testing these little units, and taller ceramic are crap compared to these. Yeah, I'm sure there's no, but if you can still buy these, buy them. They're awesome. All right, we got electric. We are running 100% wide open, high heat, okay? And now I'm going to show you about this. About if you have to put it somewhere and use an extension cord. All right, safety. But now watch. You want to see high efficient heat? The toaster turned red. That's making it hot. That's wasted energy. Now I'm going to turn off the lights. And I have my light off on my phone. And let's see if we can see how much light that is being made. Wasted energy while we're trying to make heat. Okay, you ready? And I'm going to have to feel around for this. I'll turn it. See, I put it on. Always put electrical heater on a little metal pad, no matter what. Okay, you ready? Yeah, and I got, that. But I'm going to show you this first. I don't know which way to go, so you all understand. Now I'm going to kill the light, and let's see if we see any light whatsoever, red color or light, in the back of this. And I'm feeling it. I'm feeling for it. My hand, right there. You see any light? You see any light whatsoever? Any red glow, anything? I am right at the back of it. You see that? No, you can't, because there's no light. My camera on my phone can't even find it, because that's the most efficient heating elements I've ever found in my life. Right there, there's no light. It's just a black screen of death, which is awesome. My hand, I'm going to show you what I'm doing. I just have my hand in front of it. Now I'm going to turn the lights back on, if I can find my wall here. And not stumble over my cords, because I'm showing you efficiency. Okay, efficiency, they don't rate heaters. I'm still trying to find, turn on my, there, turn my light. They don't rate electric portable heaters like they have to rate furnaces and BTUs. They just feel, it puts out this many watts. Here it is. That's why I was showing you. Nothing. It's putting out heat. It's putting out heat. Keep it off the floor, because it puts out heat. Okay? And it's 2 wires. It's not grounded. It had a so-called ground fighting Raptor junk. If you can buy these, I'm not pushing them, but if you can find them anywhere online or anywhere, buy them. The most efficient. You saw the toaster. Glows. The heat. There's no glow, and it's putting out heat up. I run this, and I set it at 65 or 70. Once I have and put it on the thermostat on auto, and it holds it. But always run them on high. Don't run them on low loads. Just run to resistance. Always run them on high and set your temperature. These are awesome, man. These are awesome. No light whatsoever. That means all the energy is going into spinning the fan and making heat. And no light energy whatsoever. You get it? Cool. Awesome. Okay. Now, these are cool. If you can find them, I'm not even talking about the name, but buy them. These are the most efficient room heater. And it says it's for a room, you know, like 12 by 12 feet or personal heater. I'm heating my whole house here. I'm heating all this with this one in here, and then, you know, and it was 22 degrees last night. And it turned on and off, and I had it set at 65 because I'm comfortable sleeping. Now I got it on 70, it's running, warming it up. You know, you keep the heat, the constant. If you like it 70, just set it at 70 and leave it. But, and now here's a kicker. I like to have it, you see, it's forced air. Infrared. Oh, infrared heaters. I got infrared heaters in my garage. All right? You know what? Infrared, you know, 120 volt. Oh, yeah, but it warms the stuff around. You notice something about infrared heaters? They make light. They make light. Yeah, they warm up stuff around, but this just heats the air and blows it. But if you put it 4 feet from any kind of something like a chair, like right where my foot is here, go that far away from it, it's not hard enough to burn you. I can put my hand in there all day long, or my toes even be nice and warm, but you want free air movement, you take one of these little heaters and warm up not just the air in the middle of the room like I'm showing you now. You take it and aim it at some physical thing that'll hold heat, like this big padded chair will hold a lot of heat. So when this heats up that chair and then the air temp, it turns off, this chair radiates the heat in the room for a fucking hour and 45 minutes. And then this turns back on and runs about 3 minutes, warms that chair up, but you don't want to put it like right here. I said you put them like 3 feet away, warm up something that holds heat, and it will keep it'll keep the whole place that way. I've been experimenting for 10 years. Okay, now I'm going to show you the safety stuff, all right? I'm going to turn on my studio lighting here, which is my LED stuff. I think it should turn on, because you need to see. Here's what you do for safety, though. You don't empower consumption, everything. But see, I'm running direct with my own plug-in because that ground fault was junk. What is it, 5-foot cord? This is like a 16 gauge cord, okay? That's totally legal. You all listed to go 5 feet. On what it's pulling is 12.63 amps, and functioning again. I'm getting 1,500. Well, it says hours. What? I need watts. I just apparently said, yeah. Okay, we're running. Well, let me turn my light off now. And 1,000, use this one. use my studio lighting. 1,458 watts. On high run, wide open. 16 gauge. What these are made will take about 1,600 watts. But if you need an extension cord to move to the middle of the room better, or heat up some AO, or when I sit, I like to keep my feet warm, you need one of these. Okay? Now this is a 16 gauge extension cord that says it'll take 1,625 watts. Should be legal. Alright, I was running this for about a half hour and letting this run on high, and it says it's, you'll listen, the plug-in got so hot, and this, where it was plugged in, was hot to the touch, where, no, it's very uncomfortable. It's that freaking, don't do that. Use a 14 gauge wire. If you're gonna, see, I leave this on while I'm gone away from home at work. If you kept here watching, don't use 16 gauge wire. This is 6 foot, 14 gauge, and it says it's good for 1,875 watts. And I plugged it in, and it works. And I was going to show you using the meter, smaller wire, the longer distance, the more resistance and the more power you lose for your heater. Plus, it makes your stuff hot. You can burn your house down. You're only using one. And I have 20 amp breakers in here, you know, like apartments or whatever stuff, 30, 15, 20. I got 12 gauge wire in this house. And I ordered it, had them build it special. 12 gauge wire back then was $400 extra over 14 gauge. 14 gauge will take 1,800 watts. For $400, I'm not going to burn my house down from using electricity. But yeah, there you go. I can show you the ohms difference between this cord here, that's a 16, and this one. But well, we could play real quick if you got time. I'll keep it on. I'm going to unplug the outlet from the wall. We're going to unplug the heater. Okay, now I'm going to take this meter and see what kind of amperage is pulling if I plug in this extension cord. All right, we're going to put it in. This is the 16 gauge, and see if it's pulling more amps or power factor or whatever. So I have to plug this. Don't use 6. Yeah, Menard. No offense, Menard. It said, yeah, here's a 5-6 foot extension cord for most home electric portable heaters. 16? No, you don't want to do it. Now we're gonna just, oh crap, I don't know if I can plug it in. It ain't gonna fit. See, what's wrong with this picture? What's wrong with this picture? 16 gauge, don't have a ground, but this don't have a, but yeah. Alright, well guess what? It loses a lot of electricity. Okay, and it gets hot. I could put the plug-in back in the wall here and show you it will go up in resistance, and the watts will go up, and the efficiency, it'll pull more amps because it's 16. But now looky here, we have a 14, $2 more. We have a 14 gauge 3-wire cable that will plug in to the wall. It's actually grounded, even though you don't need to ground. We're going to plug this in here, okay? We're going to plug that in, and then we're going to plug the 2 wires in from the heater. All right, pardon me. Well, I said I'll try to stick it in my pocket. All right, let's see if you can see what I'm doing. Yeah, that's my producer and engineering video guys didn't show up today. There you go. All right, I got that plugged in. But I want to do it. We're going to go right from the wall, okay? We're going to have this right from the wall and see how many watts it pulls. Okie dokie. It'll go and then I'll fire it up. Uh-oh, I think I just took and knocked over my studio lighting. Yeah. All right. We're at watts, 1.1 just to run the meter. All right. We're at 1.1 watts running the meter there, if you can see. Now we're going to flip through and turn this baby on high. That's the wattage, 1444.43. It's actually the same or lower for watts running full horsepower with this 6-foot extension cord compared to just this cord that goes to the heater, okay? Get it? This is from the wall. 1442, 43, 44 watt. Okay, now if I take this, we'll see how much resistance, how much more watts it's pulling when I put this meter in between here, okay? We're going to unplug it, it'll shut the heater off. We're at 1442.43, okay? I'll tell you, probably be about nothing different because I'm using a bigger gauge wire. I don't want to break my meter. I got it stuck. There we go. Got to pull it out direct. All right, now it's unplugged, so I'm not going to get electrocuted. We're going to plug this into here and that in the wall and see how we were at 1442. Okay, that distance of 6 feet, I got to put it in my pocket real quick. I'll get it back. I'm plugging this in at the end extension cord. Then I'm plugging this heavier extension cord in to the same exact outlet. Yeah, it's 3-pronged. It's grounded. That's always better no matter what. And now we're going to plug in the heater. Non-grounded because it's double insulated into here, okay? All right, we got it. We have 0 voltages, I believe. I lost my studio lighting. I need to move. Okay, there we go. We're at the same 1.1 watt. We were at 1442, 1443 watts. Direct into the wall. Over there, okay? 1.1 watts to run this meter. Now we're going to turn this baby on high again and see how much of a voltage drop in wattage. Well, it's basically voltage, amperage, everything drop. If it goes up, that's because of the length of the wire and it's not thick enough. We're going to turn it on right now, okay? Just high. All right, we're good. We're on high. We're at 1442. It's going to make a difference. It was pulling 1442 watts directly into the wall with this 16 gauge wire that is totally legal and you are listed. But look what happens. I'm running the meter and I'm running 6 feet more of an extension cord. See? And it's still running 100% wide open. And the wattage use, my energy use has gone down. Because there's less resistance. Even though I double it, there's less resistance because this, even the 6 feet, the bigger wire, coming into this metering has reduced the horsepower to go through this. It's it's electrical and electrical physics, all right? Now, look, it dropped. You think I'm lying? You saw it, 1400. Now it's taking 14, 36, 37. Still running wide open. Okay? Now, we're going to, I said, if you got 5 more minutes, I'm going to unplug it, and we're going to put the 16 gauge extension cord. Oh, I can't plug it into that. That's right. Damn it. It won't fit because it ain't, yeah. No, it won't work. I already tried. Look at that. What? It went down because the resistance, even though I doubled the distance of the wiring, the resistance is so much lower and carries so much current through this 14 gauge wire. I'm down at 1437. Okay, and we can see the amps too. No, that's kilowatts since I turned it on. Voltage, 114.7 volts. Yeah, at 120, it's between 110 and 120 here. 12.5 amp. There you go. Now we're going to plug it back in the wall and see if that goes up. Make a longer run of wire from here, not direct, but use bigger wire halfway through, and look at the difference. There's the amps, 12.5, 12.49. There's the watts. Once I flipped it, now it's been running at 15.15. After this warms up, it actually pulls a little more wattage, but there's no light. There's no light here. I'm not using any light. You see in the back of here, you can see through it with the fan blowing. There's not one single red wire showing anywhere heating. And it's putting out heat up the yang. All right, we're at 1,515 watts. Now I'm going to unplug it. We're going to go direct into the wall again. And it might go lower. It might go a little higher. Okay, you seen that? I unplugged that. It shut off. We're going to go directly into the wall. Right here. Use a meter. Yeah, my studio line. Excuse me, my studio filming producer helper didn't show up. Because I don't have one. I just do this stuff on the fly to show you. We're at 1,500, what, we at 1,515 watts, maybe? Okay, I think I got it. That's the high. Make sure I use the same outlet, high, low. Function, I don't need the meter, I just up, down, boom, boom, boom. Oh, apparently I hit the wrong button and I'm stuck on what it's doing. 90 watts. Yeah, and I got my arm in the way. It says watts. Now let's plug in directly. Okay, we're going to plug directly in here. And it says I'm on watts, so we'll see. Okay, 1.1 again to run the meter. Turn it on high. Now it's pulling 1,446. How many amps are we pulling? Yeah, it's a short distance. Kilowatt hours, that's how it was using. We're down to 115.3 volts, scumbags. I'm supposed to get paid for 120 volts I'm paying for. 12.56 amps. With the extension cord in there, with that big extension cord, I was running 12.42. It actually dropped to amperage. So there you go. Use a good cord. $2 more for this cord, okay? $2 more, and it's 14 gauge. And it has a grounded outlet and everything. At Menards, wherever. Yeah, they had, oh yeah, it worked. You got a 6-foot extension cord for most home portable heaters, electric. Yeah, they're 16 to 14. 14.2 or 14.3 indoor court. $2 more makes it highly more efficient. 12.58 amps. $1,515 amp. An extra 6 feet. 1,515 watt. And I can't remember how to hit the button for the power factor. It's 100% on high. Always run them on high and set your automatic thermostat to turn on and off. If you put it on medium or low, this is as high and low. If you put it on low, it's still taking the same amount of electricity, and it's using the resistor and the capacitor to slow it down. And you're losing heat, but you're still costing you the same as running it wide open on high and let it go. So just put it on high all the time and then set your thermometer on it so it turns on and off where you want it. You're losing efficiency if you go on medium, low, or high. It's just resistors. Okay. Yeah, there you go. We're back 1,515 watts. Well within the specs of this cord, which actually states the specifications, 1,875 watts. Okay? There you go. That's how you do it. Don't use junk like this and plug it. Even though if you can't plug in a grounded outlet to it, don't use it on your heater, even if your heater don't have one. And this is the same size as that. It don't matter. It's the same thickness outside. The wire on the inside what matters. This is rated 1,620 watts. I looked up all the specs, 1,620 watts, and pulling 1,515 watts through it. The plug-in got so freaking hot I couldn't hardly hold on to it. And the plug-in here where I plugged into the outlet, it heated up. The entire outlet was hot, not just the plug-in. I plugged this baby in here. It's 14 gauge. The outlet don't get hot. The plug-in don't get hot. It gets warm. Spend $2 if you're gonna run portable heaters. Even infrared, but look at infrared. They're awesome. They heat all the stuff around you. And look, infrared's invisible to the human eye. Okay? Infrared energy is invisible to the human eye. How do you think the old remote controls worked before their frequency? Infrared, IR remote. Boom, boom, infrared. If you got to infrared anything and you can see it, that's wasted energy. The infrared heaters warm the objects, but not the air. But look, you can see them when they're on. You can see them. You can't see a damn thing in here except through it. You don't see any red wires, nothing. They're warming up. Infrared heaters, you know they're working because you can look at them and go, look, the infrared heater's red. Well, that's wasted freaking energy, get it? You shouldn't be able to see it. There you go. All right, but there's safety. You spend $2 for a heavy cord, 14 gauge if you're going to run an electric heater. And then I'm going to plug this in and move it over there, and set it whatever, 65 or 70 I want. And I'm going to keep it 4 feet away from that chair. But even though it's only heating the air and area around, it's heating that chair. And then when it turns off, that chair is fully padded. It's like a big chunk of insulation that just sucks up heat. And that's going to release the heat while this is turned off. Get it? Oh, you don't want to go from right here to right here. You don't want to, let's point it right at the couch. No, don't do that. As I keep it about 2 or 3 feet away from a big old chair or something that holds a lot of heat. And it will warm up, and then once this turns off, that chair holds the freaking heat, and the room absorbs it, and then when it cools around, boom, and it goes again. I'm an expert on energy efficiency of heating, so you don't believe me? Just look. I'm just proving it. I've been experimenting with all this closure drape. I've been experimenting with this stuff for 15 years, and the best here, this is the best one, right here. I don't care. If you can find them, buy them, all right? I'm not mentioning, okay, Sunbeam One Touch. They were the most efficient little tiny room heater on the planet I've found. Ceramics, Lascos, towers, the $500 infrared heating coil crap junk things, infrared shit. Infrared, you know it's working. Oh, it's warming because look you can see the red glow from the frickin' heater. Well, that's wasted energy that's not going into heat. You don't see any red anywhere in here, do you? Yeah, but I got the light on. What? Ready? Yeah, you see any red in there? I got, there, you see any red in the back of this? None. And you want me to shoot it with my temp gun and see if it's putting out heat? I can shoot, look at that. You see that? There's no glow of any light. That's all efficient heat. Get it? And I could shoot with my infrared little gun and tell you what kind of heat temp it's putting out. Compare their temp coming in, shall we? Yeah. That's most efficient. They're amazing. I hope they still make them. Let's see what kind of temp we got just on the front so we can see. See, we're going to shoot the plastic on the front and see what temp it puts out. We're doing it. Oh, yeah. 132 degrees. Dungaree. Far from making stuff burn, but right there, we're getting, the plastic is 100, I'll try it again. Yeah, 135 to 138. What about down here on the metal? Just shoot it and see. 139 degrees. It's put 139 degrees and not even putting out 1 ounce of light from it. Woo! There you go. Okay, but safety. If you're going to use, make sure you're wiring in your apartment or whatever. They're using, apartments have 15 amps. I'm 20 amps plus max with 12 gauge wire in this whole house. It'll take 25 amps, and I'm running 20 amp breakers. Okay, but yeah, there you go. And we're running 1,515 watts that I'm gonna move now closer to warm up my L with my cable, my 14 gauge cable that states it will take, and constantly UL listed 1,875, so I'm way under it, all right? This thing is like 1,600 maybe, and the longer distance, more resistance. No, it gets hot. But yeah, there you go. Be safe. These are great, man. These are the most efficient little room heater that's heating this whole area. And keeping it quite comfortable, and I have it on high. It's actually kind of getting warm here. And it's cold outside, and I got the fans running. But yeah, it says it was 64 degrees in here when I started making this video. You see this? It says it's 68 right now. Just from running that thing on high that long. So yeah, it'll turn on and off, but I'm going to extend the cord out and get on my laptop, check my bills and stuff I need to pay quick yet. And I'm going to put that here about right there on top of my metal pan for safety, and my grounded 14 gauge wire, and let it boil and set it at probably 65 and on and off, and then it's not just blowing in the air, it's actually warming stuff around. And then when it shuts off, this big giant heat absorbing chair will radiate the heat back out. It's all physics, just like electrical physics, aerodynamics, hydrodynamics. It's all, you just got to figure out how it works. It took me like 10 years to figure out that's the easiest way to do it with these little tiny heaters that work awesome. But I said, if it gets down to, 10 degrees at night or 0 or below 0, I have to run my expensive propane furnace because my water lines run along the heating bent duct lines for my home, and at about 0 below I might take a risk of freezing up water lines because the only heat they're getting now is from the floor down, even though there's insulation underneath. So the water lines run right along the heat ducts, tied to them. It gets down to 10 degrees or so, I have to run the propane. But until then, I'm economically feasible, cheaper running these little electric heaters. I'm comfy. All right, just be safe. Don't be stupid. And I showed you. And if you see any red, infrared, but you can see it, it's not a good heater. If you've got an electric heater and you can see a light from it, that's wasted energy. You just saw these little buggers right here. No light. And it's putting out 132 to 138 degrees of heat. And not 1 ounce of light. They're amazing. I hope if they still make them, buy them up before they shut them down because they're awesome. All right, love you. Mwah. Peace. Love, have a heart. Hold my phone, have a heart. Thanks for watching. Be safe. But I wanted to show you the truth. I said, anything electrical that makes heat, if it makes light and you can see it, that's losing efficiency. You just saw me show you twice. There's no light whatsoever coming out of that heater, either side, with the fan blowing, and 132 degrees. That's the most highly efficient little portable heaters I've ever found. Cool breeze. Love you. All right, take care. I will be back if God and the angels let me. I'm going to get my boat out in the water this weekend. It's supposed to be 60. If it ain't too windy. See if my little trim tabs work. And I got all parts to start rebuilding the Kia because the Intrepid won't go yet. I got to do something. All right, love you. Take care. Be safe. Be you. But yeah, if you can see light from a heater, ceramic ones don't put out light. Ceramic are not efficient, all right? You find electric that's got coils that don't make any light, much more energy efficient, put out much more heat than a ceramic. I got ceramics too. They don't do what these little guys do. I said, so buy them up if you can before the communists shut them off because you can actually save money a little bit. There you go. All right, love you. I will be back, I promise. God and the angels let me. Y'all take care. Tomorrow's a new day, and you can always learn something just by looking. There's always something beautiful to notice or something to learn around you. Pay attention to what's around you, not tunnel vision, okay? Love you. All right, I'll be back. I promise. Ciao.